Good morning dear students, I am your physics professor Dr. Nagaraj. So this is my second video on laser. In my first video, which is exclusively meant for engineering students, those who are studying in VTU, that is Visvesvaraya Technological University, and these videos, as I told in my previous class, are for applied physics for CSE stream, that is applied physics for computer science and engineering stream. And of course this video, even the previous video, is also applicable for, suitable for electrical and electronics engineering stream also. So laser chapter and optical fiber chapter, this is common for both the streams. So both the stream students can watch this video and follow the contents of this video. Okay. So well, in my yesterday's video, I spoke about fundamentals of laser, what is spontaneous emission, stimulated emission and absorption, and also something about metastable state, population inversion, and before that I also mentioned properties of laser. So, and of course historical developments of laser. And yesterday's video, or my previous first video, was concluded with one sentence, that is Einstein's theory of laser, Einstein's theory of A and B coefficient. So I told you Einstein's theory of A and B coefficient will be continued in the next video. Here is the next topic. So in this video I am going to cover Einstein's theory of A and B coefficient, or Einstein's theory of laser. So this is also called as A and B coefficients. Why it is called coefficients or A and B coefficients, you will come to know about this later on. Dear students, this is also one of the important question and most expected question in the examination. You can expect this for 10 marks. Give the theory of Einstein's A and B coefficients, give the theory of Einstein's theory of laser, or starting from Einstein's theory, obtain the expression for energy density. All these are same only. Okay, so Einstein theory of laser. See, sometimes what happens, we will be knowing the answer but we are unable to make out the question. So by misjudging the question only, we lose marks. So I have seen my students, this is my 33 years of service I have put in engineering college. So I have seen many students, they know the answer but they fail somewhere to analyze the question. So questions, you should know what are the different types of questions that will appear, and answer is for same for those questions, that you should know. So one such a beautiful example is here. So sometimes they ask, give the Einstein's theory of laser, okay, or I give Einstein's theory of A and B coefficients, and hence obtain the expression for energy density. All are same only. Well, with this introduction, I am going to start with Einstein's theory of laser. Dear students, in the previous video, I was talking about interaction of radiation with matter. I mentioned three types of interaction. One is absorption, another one is spontaneous emission, one more is stimulated emission. So I take them one by one. So you have to start like this only. Number one, there are, okay, you write it like this. There are three types of interactions with matter. So radiation is going to interact with matter in three ways. Number one, first one, spontaneous absorption. Spontaneous absorption. Sometimes we also call it a stimulated absorption. Okay, what is this spontaneous absorption? Please recall, yesterday I was talking about this. If there are two energy levels, say ground state and excited state, namely E1 and E2, normally we will have more atoms in the ground state and atoms will be in the ground state. I take number of atoms in the ground state as N1. Okay, now if radiation is incident on this particular setup, when radiation of energy U gamma, so here onwards I use one separate symbol, that is U gamma. This is nothing but energy density. What is energy density? It is nothing but energy per unit volume. So energy per unit volume, that is energy density. I represent it by U gamma. Okay, so when radiation falls on this, atoms are excited to higher level. Now you think, what might be the rate of absorption? That means when there will be more absorption, when there will be less absorption, you just think. Yes, you are correct. If there are more number of atoms, there will be more absorption. Plus, if the incident energy is more, there will be more absorption. So therefore we can say, see, you have to understand only three equations. If you follow those three equations carefully, the whole derivation becomes very simple. Okay, so first equation, rate of spontaneous absorption is directly proportional to number of atoms and energy density, that is N1 and U gamma. So proportional to N1 U gamma. Okay, this is first statement. As usual, I remove the proportionality sign, then I write rate of spontaneous absorption is equal to some constant into N1 into U gamma. So I am using one constant B, that is why it is called as B coefficient, A B coefficient. Next I am going to use even A also. And dear students, we are going from level 1 to level 2, therefore I name it as B12. 12 stands for absorption, going from level 1 to level 2. So this is equation number 1. Okay, so next, this is first kind of interaction. Second kind of interaction is spontaneous emission. Yesterday or in my previous video, I already mentioned what is spontaneous emission. See, when atom is excited to higher level, so it will stay there only for 10 power minus 8 second. So that is in E2 level, this is E1 level. After spending some amount of time, it will definitely come down to ground state. While coming down, it gives out some energy. This is called spontaneous emission. Now you think, what is the requirement for spontaneous emission? Do we have to supply any energy? And the atoms and ಕೆಳಗಡೆ ಬೀಳಿಸಲಿಕ್ಕೆ ನಾವು energy ಅನ್ನು supply ಮಾಡಬೇಕಾ? No, we need not have to supply energy. Dear students, I am once again telling you, if I am using Kannada in between, it doesn't affect your flow. Okay, so already whatever I am explaining in Kannada is already explained in English. So those who don't know Kannada, you need not have to feel uncomfortable. Okay, so here and there I use Kannada for the benefit of my students, those who studied 10th standard till 10th standard Kannada medium. Okay, so ಇಲ್ಲಿ atoms ಕೆಳಗಡೆ ಬೀಳಬೇಕು ಅಂತಂದ್ರೆ ಏನು ಮಾಡಬೇಕು? ಏನು ಮಾಡಬೇಕಾಗಿಲ್ಲ. We need not have to do anything. That means we need not have to supply any energy. Just like that it will fall. Then what? Suppose if there are more atoms, there will be more fall. Less atoms, less fall. That means spontaneous emission depends only on the number of atoms. So like this equation, I write rate of spontaneous emission is directly proportional to N2. So unlike this, it is not depending on U gamma. Okay, because I need not have to supply any energy. This I write as rate of spontaneous emission is equal to some constant. See, another constant is coming now. That is why it is called as A and B coefficient. A into N2. Now write the suffix for A. Yes, it is nothing but level 2 to 1. Therefore I write it as A21. So A21 stands for de-excitation or it is de-excitation or jumping from higher level to lower level. So this is my equation number 2. So second possibility is over. Now third possibility I write here. Third possibility here, that is third interaction, as I mentioned earlier, it is stimulated emission. So next possibility is stimulated emission. So in the previous video I mentioned 3 possibilities. One is spontaneous absorption, we have. Next is spontaneous emission, we have. Next is stimulated emission, that I am going to write like this. So when there is stimulated emission, when atoms are already in the excited state, okay, that means now it is N2, and now if you send one radiation, that means we have to send one radiation now. That radiation is going to instigate, that radiation is going to stimulate. As a result, there will be de-excitation. That means rate of stimulated emission depends upon number of atoms. More number of atoms, more stimulation. Less number of atoms, less stimulation. Plus it also depends on the energy of this radiation, that is N2 U gamma. See the major difference between this and this. case. This depends on number, this also depends on number, but this will happen on its own. Nobody's support is required, but this will not happen on its own. Somebody's support is required. That's why we have this term. Okay, next is rate of stimulated emission is equal to, again a constant, n2 u gamma. Come on, tell me what should be the suffix for B. Yes, it is from 2 to 1, therefore I write it as B21. So this is now the equation number 3. So dear students, please observe these 3 equations carefully. Number 1, this one, that is rate of absorption. Next, number 2, rate of emission. Which emission? Spontaneous emission. Next one, another rate of emission. Which emission? It is stimulated emission. Okay, now let me now combine. That's all. 90% of the derivation is over. If you understand these 3 equations, rest is only substitution and simplification. So, okay, so normally what happens when we see derivation, we feel that there are so many mathematical steps and we get confused. Sometimes we get even nervous also. You need not have to sumne equation nodi takshana bhaya utkoಳುತ್ತೆ. Bhaya pado necessity illa. You need not have to be panic. ಗಾಬರಿ ಪಟ್ಕೊಳ್ಳೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಸ್ಟೆಪ್ ಬೈ ಸ್ಟೆಪ್ ಹೋಗಿ ನೋಡಿ. ಇಲ್ಲಿ ಒಂದು ಈಕ್ವೇಷನ್ ಬಂತು, 2 ಬಂತು, 3 ಬಂತು. ಈಗ ನೀವು ಸ್ವಲ್ಪ ತಲೆ ಅಪ್ಲೈ ಮಾಡಿ, ಮೈಂಡ್ ಅಪ್ಲೈ ಮಾಡಿ. ಯು ಅಪ್ಲೈ ಯುವರ್ ಮೈಂಡ್. ಯಾವ ತರ? ಹೌ ಇಫ್ ರೇಡಿಯೇಷನ್ is absorbed, definitely atoms will go up. Among those which are going up, some will fall spontaneously, some will fall in a stimulated manner. That means if you kick 1000 atoms, maybe 200 to 300 will fall spontaneously, remaining will fall stimulated. Athwa few of them will undergo stimulated, rest everything undergo spontaneous. In total, whatever is absorbed, whatever the atoms you send upward, they have to come back. They have to come back. That means this is equal to this plus this. Got it? This is what is called equilibrium condition. So absorption is equal to spontaneous emission plus spontaneous absorption. So now I go to the next step. Therefore, what we can write, under equilibrium or at equilibrium. At equilibrium, equilibrium means what? Constant temperature. At equilibrium, spontaneous absorption rate is equal to, I should write rate here, spontaneous emission rate plus stimulated emission rate. That means equation 1 is equal to equation 2 plus equation 3. Follow carefully. Equation 1, you go to the previous one and check. Equation 1, this one is equal to 2 plus 3. Okay, so now I write equation 1 is n1 u gamma, of course there is a constant B12 is equal to, come on, write for equation 2, it is n1, okay, sorry, I write the constant A21 n2 plus B21 n2 u gamma. Please check the equations. Equation 1 B12 n1 u gamma, equation 2 A21 n2, equation 3 B21 n2 u gamma. So that is what I am having here. Equation 1 is equal to 2 plus 3. Following? No? That's all. Now you keep on proceeding. What to do? First I will do one thing. Take u gamma one side. Okay, so that means that also here. Then B12 n1 u gamma minus B21 n2 u gamma is equal to A21 n2. So this is a very simple step. I transferred it that side. Then I take u gamma common factor into remaining B12 n1 minus B21 n2 is equal to A21 n2. So follow carefully. Next, I write only for u gamma. So u gamma is equal to, so A21 n2 divided by, this whole thing will go to denominator, so B12 n1 minus B21 n2. Okay, so I hope you are following the smooth, it is going in a smooth manner. So next what I do, I write it as u gamma is equal to A21 n2 divided by, in the denominator I take this as a common factor, that is B21 n2 I take it as common factor, B2, this whole thing I take it as a common factor, then this becomes B12N1 divided by B21N2 minus 1. Please check carefully. So when I take it outside, this has to be divided by that, otherwise it cannot be taken as a common factor. Next, cancel N2 and N2. So now you have U gamma is equal to, in the numerator only A21, so A21. In the denominator I have B21 into B12 divided by B21 into N1 by N2 minus 1. So is there any problem if I write like this? I don't think there is any problem. So I call it as equation number 4. Okay, actually N1 annodu, it is number of atoms in the ground state. N2 means number of atoms in the excited state. Definitely N1 is greater than N2. There is a relation connecting N1 and N2, that is actually called as Boltzmann equation. According to Boltzmann, so directly we borrow this equation. This is the problem in derivation. Sometimes without knowing the equation only we borrow it. Okay, so we call it as we know that, even though we don't know exactly that equation, even though we have not studied it earlier elsewhere, sometimes we used to write anta kadege we have to remember those equations ashtene. So according to Boltzmann ಈ equation ಅನ್ನು ನಾವು ಬಾರೋ ಮಾಡ್ತೀವಿ. ಅಕಾರ್ಡಿಂಗ್ ಟು ಬೋಲ್ಟ್ಸ್ಮನ್ ಏನದು equation? n1 divided by n2 is equal to e to the power of h nu divided by kt, where nu stands for frequency, k for Boltzmann constant, t is temperature, h is Planck's constant. So this is equation number 5. I substitute equation 5 in equation 4. We get. So now let us proceed. What happens? ಈಗ ಇದನ್ನ ತಗೊಂಡೋಗಿ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತೀನಿ. So when I do that, I get U gamma is equal to A21, that is numerator, A21 whole thing divided by, okay, this I just remove. This is actually for the previous diagram, that is N1 greater than N2. Okay, A21 divided by B21, follow carefully, B12 by B21 as it is, B12 divided by B21 as it is. In the place of N1 by N2, I write e to the power of h nu by kt minus 1 as it is. Call this as equation number 6. I repeat once again. First, I took thermal equilibrium condition. So I borrowed 3 equations from the previous part. In the previous part, so rate of absorption, rate of emission. So under thermal equilibrium, they are equal. So absorption is equal to sum of the emissions, and then I substituted and made some simplifications. In between, I borrowed one equation, that is nothing but Boltzmann equation. Now I am here. Dear students, follow carefully. You all have heard of Planck's quantum theory of radiation. Max Planck ಅಂತ ಅವನೇನು ಹೇಳ್ತಾನೆ, when a body emits energy is emitted in the form of a discrete packets. Each packet of energy is called as quantum of energy is emitted, and each packet of energy is having E is equal to h nu ಅಂತ ಹೇಳ್ತಾನೆ. But while coming to that conclusion, he derived one expression for energy. Normally we write E is equal to h nu, but E is equal to h nu or n into h nu. Before arriving to this equation, he derived one more equation, that is energy density equation, that is according to Planck's quantum theory of radiation. U gamma is equal to 1 divided by B21, 1 divided by e to the power of h nu, sorry, it's not 1 divided by, I am doing mistake. It is not 1 divided by 8 pi h nu cube divided by c cube into 1 divided by, so follow carefully, h is Planck's constant, nu is frequency, c is speed of light. It is 1 divided by e to the power of h nu divided by kt minus 1. This is equation number 7. So now check equation 6 and 7 carefully. In the place of A21 by B21, so from equation 6 and 7 we get Please just watch this. A21 by B21. In place of A21 by B21, we have 8 pi h nu cube by c cube. So we get A21 divided by B21 is equal to 8 pi h nu cube divided by c cube. This is one result. I call it as equation 8. And one more comparison. So just comparison. I am comparing. Nodi, in the place of A21 by B21, I have 8 pi h nu cube by c cube. Next, in the place of B12 by B21, we have nothing. That means we have 1 here. That's all. So we have 1 before this. H nu by kt, h nu by kt. This is matching. So in place of B12 by B21, we have only 1. That is B21. Well, so in the place of B12 by B21, in the place of B12 divided by B21, we have 1. This is equation number 9. Okay, so B21 B12 ratio is 1. What actually it means? What is actually B12? Go back to this. B12 stands for spontaneous absorption. B21 stands for stimulated emission. According to this relation, rate of spontaneous absorption is equal to, okay, you can write it as B12 is equal to B21. So this is the final relation. So according to this equation, rate of spontaneous absorption or spontaneous absorption coefficient is equal to stimulated emission. This is the main conclusion of Einstein's theory. So according to this equation, okay, write these two equations once again. According to Einstein derivation, we got U gamma is equal to A21 divided by B21 into 1 divided by B12 divided by B21 e to the power of h nu by kt minus 1. This is from Einstein's theory. That is equation number 6. Next, according to Max Planck, U gamma is equal to 8 pi h nu cube divided by c cube into 1 divided by e to the power of h nu by kt minus 1. This also you can borrow directly. So like Boltzmann equation, nodi, in the previous step I borrowed Boltzmann equation straight away. Like that you can borrow Planck's quantum theory of radiation equation from quantum theory. Now after comparing these two, I get the first relation. That is A21 by B21 is equal to so much. And then after comparing this, in the place of B12 by B21, nothing is there means there must be 1. I can write it as 1 into. That's why I have this relation with me. Now let us make some conclusions on these results. First conclusion, spontaneous absorption is equal to stimulated emission. That means B12 is equal to B21. Okay, before that, dear students, now we come to know that B12, B21 both are same. Therefore, we can write this relation as U gamma is equal to A21 divided by B21 into, so this we can cancel. It becomes 1 divided by e to the power of h nu by kt minus 1. That means A21 by B21, and since there is no one more B, I can simply write this as U gamma is equal to A divided by B. So you need not have to put suffix here because there is no one more B. Till now there was one more B because there was B12 B21, but now we proved that B12 is equal to B21. ಎರಡು ಸೇಮ್ ಅಂತ ಪ್ರೂವ್ ಮಾಡಿರೋದ್ರಿಂದ ಡೈರೆಕ್ಟ್ ಆಗಿ ಒಂದು B ಅನ್ನ ತೆಗೆದಾಕಿ ಬರೀ ಡೈರೆಕ್ಟ್ ಆಗಿ B ಅಂತ ಬರೀಬಹುದು. A divided by B into A divided by B into 1 divided by e to the power of h nu by kt minus 1. This is the expression for energy density. So I told you, no, question will be like this: give the theory of laser, Einstein's theory of laser, or give the theory of Einstein's A and B coefficient, or derive the expression for energy density starting from Einstein's theory. So for all that you have to do up till here. After that, conclusions. Sometimes they will ask even conclusions also. So what are the conclusions? Okay, so now let us draw some conclusions. First, that's what I was talking. So first conclusion, B12 is equal to B21. That means rate of absorption is equal to rate of emission. That clearly shows that whatever the energy you supply, part of it is used to excite the atom, part of it is used to de-excite the atom. So rate of spontaneous absorption is equal to spontaneous emission. I will come back to this conclusion once again. Anyway, first conclusion, spontaneous absorption rate is equal to stimulated emission rate. This is first conclusion. Second conclusion, see, we are interested in lasing action. Lasing action means I want to emit more number of photons. More number of photons I want to emit means I should excite more atoms to the higher level. So first of all, I should take more atoms to the higher level. That means I have to pump them. Pump ಮಾಡಬೇಕಲ್ವಾ? ಜಾಸ್ತಿ atoms ಅನ್ನು pump ಮಾಡಿದಾಗ population ಜಾಸ್ತಿ ಆಗುತ್ತೆ. So ಜಾಸ್ತಿ atoms ಅನ್ನು pump ಮಾಡಬೇಕು. More atoms if you want to pump, what all you have to do? Supply more energy. This is what my common sense says. If I want to have more output, I should kick more atoms. To kick more atoms, I must supply more energy. This is what the general thinking. That means if incident frequency increases, my common sense says, my thinking says, there will be more stimulated emission. ಗೊತ್ತಾಯ್ತಾ? So ಜಾಸ್ತಿ ಎನರ್ಜಿ ಇರ್ತಕ್ಕಂಥ ರೇಡಿಯೇಷನ್ ಅನ್ನು ಕಳಿಸಿದ್ರೆ ಸ್ಟಿಮ್ಯುಲೇಟೆಡ್ ಎಮಿಷನ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ ಅಂತ ನನ್ನ ಮೈಂಡ್ ಹೇಳುತ್ತೆ. If I send radiation of higher frequency, means as frequency of the radiation increases, rate of stimulated emission increases. This is what my conscious says. But look at this relation. If nu increases, which one will increase? A will increase, not B. I want B to increase. What is that B? Go back to this. B andre ಏನು? It is stimulated emission. A means what? Spontaneous emission. I want lasing action, therefore I want stimulated emission. I want B to increase, not A. Okay, if I increase A, it gives you ordinary light. Okay, so according to this relation, if I increase frequency, A21 increases. So second conclusion, A21 is directly proportional to cube of the incident frequency. So in the energy level diagram, if I send more radiation or radiation of higher frequency, there will be more spontaneous emission than stimulated emission. So it is actually an adverse effect. I thought if I supply more energy, there will be more stimulated emission, but according to this relation, it is not so. So whatever you want to achieve, the basic purpose itself will be destroyed, is not served. Andre ಜಾಸ್ತಿ ಎನರ್ಜಿಯನ್ನು ಕಳಿಸಿ ಸ್ಟಿಮ್ಯುಲೇಟೆಡ್ ಎಮಿಷನ್ ಅನ್ನು ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ಯು ಹ್ಯಾವ್ ಟು ಥಿಂಕ್ ಅಬೌಟ್ ಸೆಂಡಿಂಗ್ ದ ಎನರ್ಜಿ, ಥಿಂಕ್ ಅಬೌಟ್ ದಿಸ್ ಬಿಫೋರ್ ಸೆಂಡಿಂಗ್ ದ ರೇಡಿಯೇಷನ್ ಆಫ್ ಹೈಯರ್ ಫ್ರೀಕ್ವೆನ್ಸಿ. ಸೊ ಹೈಯರ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ರೇಡಿಯೇಷನ್ ವಿಲ್ give more spontaneous emission than stimulated emission. So that's the conclusion. So two conclusions. Number one, rate of absorption is equal to rate of stimulated emission. Second one, incident frequency increases. If incident frequency increases, spontaneous emission increases, not the stimulated emission. Understood? Now coming back to the first conclusion, one more. Okay, coming back to the first conclusion. Well, I have two levels, ground state and excited state, say E1 and E2. Okay, atoms are there in the ground state, more number of atoms are in the ground state. Now you send the radiation. When you send the radiation, atoms are absorbed, so this is B12. So when atoms are absorbed, they will go to higher level, okay, and they will come down to ground level, that is B21. Okay, according to previous relation, B12 is equal to B21. That means your incident radiation has got equal probability of sending the atoms to higher level, taking atoms from higher level to lower level. That means if you send let us say if you send 100 unit of energy, 50 of that is used to excite the atoms, 50 of that is used to de-excite the atoms. So it is no loss, no gain. That means if you have only two levels, you cannot achieve population inversion at all. So you cannot achieve lasing action at all. So just by having ground state and excited state, it is impossible to achieve lasing action, because if you send the radiation, it will kick atoms to higher level, also take atoms from higher level to lower level. Therefore, it is better to have one intermediate level. This is what I told you in the previous video. Einstein's theory tells you about the necessity of another level. That level I already called as metastable level. So when you kick atoms, some of them will come and sit here. Our incident radiation has got equal probability to take from here to there, there to here, not from here to here. So this transition is not possible by this radiation. This radiation will cause transition only from here to there, there to here, certainly not from here. So better you take the atoms, send them to some safe level, see that they will sit for a while, afterwards you ask them to come down, then you get a laser, and that is our intention, that is our main purpose. So Einstein's theory gives you many important conclusions. Number one, B12 is equal to B21. That means only two levels not sufficient for lasing action. You must have at least three levels. Among them, one is ground level, one is excited level, one is metastable level. When I say one metastable level, it is not just one, it is only name. When I say one excited level, it is not just one excited level. There can be many excited levels. There can be many excited levels. All put together, I call it as excited states. Okay, this is one conclusion. Another conclusion, frequency of the incident radiation increases, spontaneous emission increases, because A21 proportional to nu cube. I hope you got it. This is one of the important derivation. I took more than 20 minutes for this. Anyway, detailed derivation part is available in my notes. Please go through it. So well, I stop this video here. ಸ್ವಲ್ಪ clumsy ಆಗಿದೆ. Please try to make out the steps one by one, and the derivation is available in the PDF which I already posted in the description box. Dear students, please tell your friends also to watch my video. Okay, you are going to get the benefit from my videos. You can easily comfortably answer all the questions, whether it is your internal test or main examination. With this, I am going to stop this video. In the next video, I will come back to you with conditions for lasing action, requirements for the lasing action, and construction and working of semiconductor laser. Okay, till then, goodbye. Thank you very much.